Hi guys, welcome to my YouTube channel Cybersecurity Ranger. Today I'm going to talk about ARP protocol, address resolution protocol. How does it work? How ARP poisoning can be done? And then what is the impact of ARP poisoning on the target system? So let's first talk about the ARP protocol. How does it work? So I've created this small simulation in Packet Tracer. So we have three hosts and they have not communicated with each other till now. So if we open any host, for example, this one, and if you go to the command prompt, ARP space -a basically shows the ARP entries. So every system has an ARP cache which has the IP address and the MAC address of the host with which it has communicated. And once it has this entry, next time if it wants to communicate, it will just fetch the MAC address of that host and then start sending the messages. But at this point, because none of these hosts, they have communicated with each other, so all of these hosts, their ARP cache is actually empty, right? So we can check this host, for instance. So there's no entry in the ARP cache, right? So let's try to go to the simulation mode, and I'm going to send a ping request from this host to this host. But since it doesn't have the MAC address, so the ARP protocol, which resolves the IP address into the MAC address, will try to find out the MAC address of this particular host. So initially, you will see that the ARP packets, they are going to be broadcasted among all these hosts, right? So whoever is on the network. So let me just drag it here so that we can see the protocol that is going to be working. So let's try to send a ping request. So I'm going to send from this host to this host, and let's see what kind of messages will be sent. So you can see here, I haven't started the simulation, but you can see that since I'm sending an ICMP, but the host doesn't know the MAC address of this host, so it is going to use the ARP protocol, which is a link layer protocol, to find out the MAC address, right? So I'm going to play this now. And you'll see that the ARP packets will be broadcasted towards this host and this host, trying to find out who has the MAC address of this IP, right? So let's play. So this is the ARP request coming to the switch. And then from the switch, it is going to be sent on this link and this link, right? Because we have two hosts. So if I had more hosts, the broadcast will be done to all the hosts. Since this host doesn't have that MAC address, it just dropped the packet, but this host has replied back to give the MAC address to this host. And now, once it has got the MAC address, it is going to send the ICMP packet, as you can see it on the right side, to the host, which is meant to receive this ICMP packet. And then obviously this host is going to reply with an ICMP reply message. Okay, now I'm going to switch back to the host. And let's see now what this host has in the ARP cache after receiving the MAC address. So if I run the same command again, it's going to show you that this 10.3 has this MAC address, and it still did not get the MAC address for this PC. So if I try to send an ICMP packet from here to here, again, it is going to broadcast the ARP on both the sides and try to find out the MAC address of this one. And then you will see the same thing happening again, right? So let's try to send it from here to here. From this host to this host, and let's play. And then you can see on the right side again, an ARP packet has been sent, and it will be sent again on both. All right, so there's some kind of, yeah, so that was the previous ICMP, I think, that went here. So now you can see the ARP packet coming back, right? And once it has received, it will basically reply back with the ICMP. Okay, now once this is done, let me just stop the simulation here and let's go back. And now you will see that it has got the MAC address of both the hosts, right? So this is how the ARP protocol works. Now let's switch to our virtual machine. All right, so this is the target machine Windows 10. So let's look into the ARP cache of this target. You can see here that we have the IP addresses and the MAC addresses of those IP addresses with which this machine has communicated. Once we do the ARP poisoning attack, you will see that the MAC address, which is 0050 and ending with 2F, it is going to be replaced with the MAC address of the attacker's machine, which in my case, the MAC address starts with 00 and ends with E7, right? So now remember that whenever this machine is going to send a request on the internet, it actually sends it to the gateway. The gateway is, in our case, is 36.2. So the idea is to ARP poison this target machine and replace this MAC address of the gateway with the MAC address of the attacker's machine. So let's get started. So the IP address of this machine is 36.141. So the tool that I'm going to use, there are different tools that can be used to perform ARP spoofing or ARP poisoning attack. The first tool that I'm using is called ARP Spoof. So ARP Spoof -I, and then you have to give the interface ETH0 in our case. Let me just zoom in. And -T is the target. So the target is 192.168, sorry, .36.141, right? And then the IP address of the gateway is 192.168.36.2. So what we are trying to do is that ARP poison this victim and tell him that if you're looking for the MAC address of this, the MAC address is the MAC, the attacker's MAC address, right? So this is one-way spoofing towards the target machine. At the same time, we have to ARP poison the gateway as well and tell him that if you're looking for the MAC address of 36.141, then here is the MAC address. So we just reverse these IP addresses. So this time we're trying to poison the gateway and tell him that if you're looking for 36.141, I have that MAC address, right? Okay, let's go back to the target machine and see if there is any changes in the ARP cache, because previously it was 00502F. And let's check if the ARP poisoning has been successful. So as you can see that the 36.2, the MAC address has been replaced by the MAC address of the attacker. So it was 0050 previously, and now it is 000C, which is the MAC address of Kali Linux, right? Now, what we want to do is that once the ARP poisoning is done, what happens is that now the traffic of this target machine is going to be forwarded instead of the actual gateway to this MAC address, which is attacker's MAC address. Now, if you start a listener, if you start a sniffer now, it will capture every packet that is going through. But before that, we need to run another command, which is echo1 /proc sysnet IPv4 IP forward. Basically, this command makes sure that due to our poisoning, the traffic doesn't get killed and it gets forwarded through the attacker's machine, right? So we just want to make sure. By default, the value of this variable is actually 0, so we need to change it to 1. And that's what we have essentially done, right? So now what I'm going to do is that I'm going to use tcpdump. If you write -I and ETH0, it basically will start, without mentioning a protocol, it will start capturing all the packets that are coming in. But we are not interested in other traffic. We are interested in, for example, let's just say that if we are interested in ARP, then it will only capture the ARP packets. If I'm interested in the TCP packets, I'll just mention the name of the protocol, TCP, and it will start capturing any TCP traffic that is coming from the target. Right now, nothing is there, so it's not showing anything. But if I go and just open a web page, let's just say Google, you will see that it will start blasting with the traffic, the TCP packets, right? Again, there are different ways you can use the TCP. If you write tcpdump -h, you will see all the options. Here, I is for the interface. If you want to write the packets and save them in a certain format, like a PCAP file, for example, that you can later on open it in the Wireshark, you can use -w to save the file and then give the file name, right? So what I'm going to do now is that I will just go back just to reduce the traffic. I'm going to close this page. Now, this is a login page, which is using HTTP. So it has a username and password field. So I want to capture this username and password in tcpdump. So I'm going to use tcpdump -a. S0 is for the packet length, and S0 basically means that the packet length should be unlimited, and I'm going to capture the traffic on port 80 because HTTP uses port 80. So right now there's nothing, as you can see, but I go to the target and I open this page. I'm just going to write my name here. I'm going to write a password 1 2 3 4 5 6 7 8, and then I press enter. Don't save. And when we go back here, you can see that it has captured the HTTP request and response. Now, there are 30 packets captured. Now, either you can scroll up and then try to look for the username and password. Here, you can write a script to parse this capture. What I'm going to do is I'm just going to use a simple method. I'm going to capture this whole traffic. I'm going to copy it. Going to open Notepad++. Going to paste it here, and I'm going to press Control F, and I'm going to search for password, right? So now you can see here that I was able to find the username, Asad Raza, and then I was able to capture or find out the password 1 2 3 4 5 6 7 8, right? So this is how you can perform ARP poisoning by using ARP spoof. You can capture the traffic using tcpdump. It's not necessary that you have to use ARP spoof and then you have to use tcpdump. There are different ways. You can also start the Wireshark and start capturing the packets using Wireshark while you're doing ARP spoofing. So I'm going to stop the ARP poisoning here. I'm going to close this terminal, stop this poisoning as well. All right. So I have already, in one of my videos, I have shown ARP. ARP can also be used to launch ARP poisoning attack by using the GUI version. I hope you have enjoyed the video. Please like and subscribe. Thank you.